Hello and welcome to section 8 in our journey to learn Go. In the previous section, we covered a practical Go topic which was handling files and serialization formats. In this section, we'll cover Go's support for databases. We'll talk about popular relational databases like MySQL, and then we will visit the world of NoSQL databases by exploring MongoDB and BoldDB. We will conclude by building a database layer in the Hydra software system. The database layer of the Hydra will be able to communicate with either MySQL or MongoDB. Now let's discuss how to work with MySQL in the Go language. In this video, we will discuss the database SQL package, which is the key for SQL databases in Go. Then from there, we'll see how we can read, modify data in MySQL using Go. We will need to use shown two links to explore Go's database support for SQL-like databases in general, and to also explore Go's SQL native package, which we will be covering shortly. The database SQL standard package provides a generic interface that exposes a bunch of common methods and interfaces that we can use to access and manipulate databases. The package contains a connection pool and it is thread safe if used correctly. It must be used in conjunction with a driver package that supports a specific database. So for example, if we need to connect to MySQL, then we use a generic SQL package that exists in Go standard library. And we also would need to use a MySQL specific package which will make use of the standard library package methods and interfaces. And we'll see shortly how to do that. People who write SQL database drivers in Go usually exposes their drivers via the database SQL package. To know the answer, let's visit the driver's GitHub page and dig into the entry point code. The driver GitHub page can be found in the shown link, which was also in the previous slide. So the entry point code exists in the driver.go file, and what I would like to show you is this function here. So this is the init function, which we have covered in a previous video. And basically what it does is execute the function code before anything else in the package. So inside the init function here, you notice that we call another function from the SQL package called SQL.register, which takes two arguments. The first argument is a string representing the type of driver that we're trying to build here, which will be called MySQL. And the second argument is an object which represents the actual driver, which does the database interaction and database handling functionality. The SQL package is basically the standard database SQL package which exists in Go standard library. Because the init gets executed before anything else, then we know for sure that whenever we include package MySQL in our code, this code will get executed right away. The underscore symbol in the import statement is a way to silently load the package, which means we load the package, but at the same time we indicate that we will not call methods directly from this package. However, the action of loading the package, even if it's silent, will invoke the init function of the package, which was the code we just covered. And the init package of the MySQL driver will register the MySQL driver objects with the database SQL package. And this will allow us to use the database SQL package functions and methods directly in our code and have that code then translate into concrete implementations in the MySQL driver package. So the first function we will cover is called SQL.open, which is used to obtain a database object. The database object is what we use then to execute queries and commands against our database. The first argument to SQL.open is the database driver we're trying to load. And as we covered in the MySQL driver code, the name of the driver is called MySQL. The second argument is a connection string we would use to connect to the database. The SQL.open function will return a handler to our database connection, which we then can use to issue queries and commands to our database. The function will also return an error object, which should be nil if no errors were observed. If we go to the MySQL driver GitHub page, we'll find a full description of the connection string, which we can use as an argument to the SQL.open function. So it takes a username followed by the password, then our protocol, which we'd use for the connection, followed by the database name. Now it's time to have fun with MySQL. So I will use the popular MySQL Workbench software to explore our database. So I already created a database called Hydra, which includes a table called personnel as shown. And I populated the table with some data. The personnel table hosts information about some of the Hydra's crew members. It includes an ID for the crew member, the name of the crew member, the security clearance, and the position of the crew member. It is worth mentioning that depending on your operating system, you need to watch out for case sensitivity when naming tables and columns. In my case, I used an uppercase letter for the first letter of the table name, and I used uppercase letters as the first letters for the column names except for the ID. To read data from the standard database SQL package, we use the query method to retrieve a result set of multiple rows. Whereas if we need to only retrieve a single row from our query, we use the QueryRow method. The query method returns an object type called rows, which is basically a struct that supports some useful methods. The rows object type can be used to scan and iterate over the data returned from our query, and we'll see very shortly how to use it. Before we start coding, let's first visit the MySQL package GitHub page again, and in there, under the installation section, we'll find the go get command needed to deploy the MySQL package to our computer. So we'll run this command, and that retrieves the latest version of the MySQL driver for us to use in our Go code. Let's create a database handler folder for our work, which will live underneath the Hydra folder. And then in there, we'll create a MySQL handler folder, which will host a MySQL handler.go file, which is where our code will live. We'll start by defining this package as main, because we'll put all of our test code in here. We'll import the standard database SQL package, the log package, and we'll import the MySQL driver package with the blank identifier or the underscore. The act of loading the MySQL driver package will ensure the init function gets called, and the reason why we use a blank identifier is because we will not be calling methods from this package directly. Next, we would create a struct which will represent the crew member information. So it will include the crew member ID, the crew member name, crew member security clearance, and the crew member position. Then we create a new type called crew, which is basically a slice or a collection of crew members. Now in the main function, we'll start by calling SQL.open to get the database handler. And the arguments would be our driver name, which is MySQL in this case, as well as the connection string to the driver. Connection string shows the username, the password, the database name, and it also includes an option to parse time. So when we talk about database support for a programming language, how dates and times are supported and parsed is an important point. So the Go MySQL driver supports translating date and date time fields to the Go time object type. And we can tell the MySQL driver that we would like to convert any MySQL date or datetime field to a GoTime object by appending parseTime equal true as a property to our connection string. And we use a question mark to indicate that we are adding a property. Now let's write a function to retrieve some crew members based on their positions. So the function will take the database handler as an argument, as well as a string slice containing a list of crew positions. So let's say we're looking for crew members who are either mechanics or biologists. So let's go and explore this function. So first thing we do is prepare a SQL query string. So we'll use fimp.sprintf to format a string, and then there we will write the query that we need to execute in order to retrieve crew member informations based on their positions. So we'll select the IDs, names, and security clearance and position from the personnel table, where position is in the supplied string slice. And for the purpose of our query, the string slice will need to be joined with a comma. That is because we need it to look something like this. So if we collect all of our query in real time, it should look like this, assuming that we passed mechanic and biologist within the string slice. Now, next thing we do is call a method called query, which belongs to the DB handler object type. So query would execute a string query that is supplied to it, and will return the results as a rows object, as well as an error object result, which would be nil if no errors are detected. An important remark is that passing the database handler like this whenever we need to use it instead of recreating a new one is the advice approach because it ensures that database handler is getting reused and it makes a function easily testable. And that's how the design should be whenever we work with database handler objects in Go. So we created the database handler once here by calling SQL.open, and then we pass it to our queries as shown instead of creating a new one. First thing we, after calling db.query, would be to check if the error was nil. If it's not nil, then we know there is a problem, so we log an exit using log fatal. This will exit our program with this error message. Otherwise, if we get to this point, then we start thinking about cleaning our resources. So we call defer with rows.close. By doing this, we ensure that rows.close gets called right after get crew by positions is done. An important remark here is that when the query succeeds, a connection from the database connection pool gets allocated to us, and then the connection is released when rows.close is called. So it's very important that we always close the rows object when we're done with it. Now, next thing we do here is to create a variable called readVal, which means return value, and it will be of type crew. Crew, as we mentioned earlier, is a slice of crew members, so it's a collection of crew members. And readVal will host the result of our query. Rows allow us to retrieve the columns returned from our query by calling rows.columns. So let's get the columns from our query. So I'll ignore the error here for now, and we just log the column names that were included with our result set. A very important method we need to use when we are going through a query result set is the rows.next method. So rows.next would return true as long as there's something exists in the result set of our query. So we can just use it with a for loop in order to iterate through each row from the result set. So for each row of the result set, we will create a variable called member, which is of type crew member, to host the data retrieved from the current row. And then inside there, we would need to call a method called rows.scan. So scan could be used to retrieve values from the query result sets and assign them to the supplied arguments. The supplied arguments to the scan method in this case would be the struct fields for the member struct object. So those will be the crew member information, which will correspond to the row in the database. So each one of those struct fields correspond to a field in the row in the database. Next thing we do is to check if there are any errors detected. If any errors are detected, we use log fatal to log then exit our program. And the last thing we do is to append the member to the readVal slice. We use the append function for that, which would take our slice as the first argument and the item we would like to add as a second argument. So when the for loop is done, we can call a method called rows.error, which will let us know if any errors were encountered while we were iterating through our result sets. If any errors were detected, we would log them, then exit using log.fatal. Otherwise, we would return readVal, which is basically the list of crew members which we have collected from the result set. Perfect. And that's how we can run a query using the database SQL driver and then iterate through it using rows.next and rows.scan. Now back to the main function, an important remark is that the strings passed to our function needs to be surrounded by single quotations. That is to ensure that the select query that we put together in our function would work. And we'll see now why is that important. So the single quotes are important because if we run our select query without them, as shown, you can see here that we would get an error. So the syntax for the in clause need to include single quotes. So let's run the query, and we can see here we have a bunch of results where the crew members are either mechanics or biologists. Now let's run our code using go run, and let's compare the results. So we see here that the results actually do match. So Telma is number 1, Shanika is number 2, and Alice here is the last one. So our code worked. Perfect. What if we want to retrieve a single row? So we use QueryRow in this case, which is a method that belongs to the pointer to DB object. And we provide the actual query to the QueryRow method. QueryRow returns a row object, which exposes the scan method, which we can use to retrieve the row values. Let's write a function to use the QueryRow method. This time, let's run a select statement to return a crew member based on their ID. So in order to do this, we can call QueryRow, and then our first argument should be a string containing our query. And for every parameter that we would need to add, we'd use a question mark in our string. And then the second argument for QueryRow would be the ID. So this will return a row object, which we then can use by calling row.scan in order to fill data on a crew member type object called CM. So we define it here already as a return result, so that's why we didn't need to define it inside the function. Then if any error happen, we log an exit, otherwise we return. This is called a naked return because we already have defined a return result name. Let's run our code again using go run, and it worked. So I ran the new function, which is called getCrewMemberById, with the ID argument of value 11 to look for a crew member with ID 11, and we got a hit. So our code works here. Now let's talk about modifying data. In the database SQL package, if the query is not expected to return any rows, like for example, if we're executing an insert or an update command, then we need to use the exec method. So the exec method would take a query string and it would take arguments for that string. Exec returns a result object which includes two methods. The first method is called lastInsertID, which indicates the last inserted ID by the exec command. And the second is called rows affected, which returns the number of rows affected by the command executed by the exec method. So let's get to see that in code. So let's write a function called addCrewMember to add a new crew member to our personal MySQL database table. It will take the database handler as an argument, as well as a crew member object, and it will return an int64 type. int64 being the ID that we added. So when we use exec, it's similar to the query and QueryRow methods in that you can use question marks to indicate parameters you need to add later to your query string. So the query string is your first argument, and then for each parameter that you need to add via a variable, you would place a question mark, and then using the crew member object passed, which should have the information of the crew member we're trying to insert into the database, we can then fill the question marks. So we'll use name, security clearance, and position. And then for our database, the ID is key of the database table, and it also supports auto increment property. So the ID will be auto-generated when we insert a new personnel, and it will get a new ID. So if we detect any error, we just log and exit. If not, then we can check the rows affected as well as the last inserted ID, and then log them to inspect our code. And at the end, we return the ID, which is the ID of the crew member added. So this is the auto-generated ID, which should get created when the insert command goes through. Now let's call add crew member with the name Steve B, for example. So that's a crew member object, which represents the crew member we're trying to add, and that's our database handler. And that crew member is a function we just covered. Now let's run our code by using the go run command. And we see here the output says that there was one row affected, and the last inserted ID was 59. So how about we query ID 59 and see what we get. And sure enough, we get Mr. Steve B, which we added here. Security clearance was 4, and the position is a biologist. So the command succeeded. Perfect. In this video, we explored the practical topic of SQL databases in Go via the database SQL package. We focused on MySQL by running queries and commands to the database from Go.